since the day one of the first edition. Thank you very much for that. Société Générale IT department support us since last year. So we are really happy to have them on board. And if you want to share cybersecurity with SOC and CERT member, there's a lot of good resources inside this team. So let's go to Twitter to exchange with them. We are very proud this year to welcome ANSSI for the first year. ANSSI is a French government of defensive security agency, and we are very proud to have them also on board. And last but not the least, silver sponsor, Synactive, since last year, this red teaming, pen testing, and auditing company support us. Thanks for that. We also receive support in a different way. We have used this year and since last year Pretix. Pretix is free software and a software solution to manage event. It is a full feature management solution. If you have, if you run a festival, if you run a conference, let's give a look. They have and implement a lot of useful feature to run that kind of event. We have used it on a SaaS model, but you can run it on-premise. So yes, we really want to have a look on it. And last, Lille University give us access to their Zoom plan. So thanks for that. We want to share also one point because virtual edition and physical edition of an event is quite different and has a lot of impact on expense. And in our case, it is a big drop in of our expense. No more travel reimbursement for speakers, no more on-site communication, no more catering, no more shamanics. It is a private job for last year attendees, and so on. So it has an impact. So we have decided to invite our this year sponsor to stay sponsors for next year at no cost. It was a decision quite easy to do, in fact, and we want to be transparent with our sponsor, and we have take this decision. One question we have to talk about: do you think Zoom is a free software, right? Not sure at all. That is a TLDR answer, but we want to share more, a little more, and share why we have decided to go to Zoom instead of, for example, Jitsi or Big Blue Button. It is our argument. We can have a longer discussion on Freenode if you want. Our argument is a small team. We are a small team, 4 part-time people to run the event. So we are not video expert, and we decided to emphasize the quality of rendering for our speaker works, and we really want to expose them in the most viable way. So we have taken a least risk approach and have decided to use Zoom. We also received support from Lille University, as previously said, with our Zoom plan. So we have shared. You just have to make your own idea about it. A new thing, we are going to have a concert online. Yes, we are maybe the only guys that decided to set up a concert the first time when they switched to virtual, quite not obvious decision, but it is our. So let's talk about the artist, Clément Oudot, which is a free software developer and the lead developer of the web SSO product Lemon LDAP NG. Is also an artist. Is a songwriter and a singer. He writes French song. He distributes them under a CC license, and is going to propose us a live concert tomorrow evening at 5:15, and you've got the URL of the concert there, but you don't rush to note it. It is on the schedule. Everything, the bio, the SoundCloud account of Clément, and the URL of the live concert. So it is it will be so tomorrow evening. Let's talk about just a moment about the conference. You are going to be able to ask questions through the chat, or we preferred through the Q&A button on Zoom. Speakers will answer to them at the end of their talk, if it is remains time at the end. Discussion, I've got an error. It is PTS 2020 on Freenode and not PTS 20. If you want to have a longer discussion, PTS, yes, PTS 2020 on Freenode. And on Twitter, you can follow PathoSoundCon Twitter handle, and if you want to use a hashtag, it is PTS20. So we are going to have the keynote in the next 4 minutes. So we are going to have a short pause between the stage will be taken by Pauline and Alexandre. So we are kicking off our event with Pauline and Alexandre for a keynote, a 20-minute keynote. Please welcome us.
Okay, good afternoon and good morning for some and good evening. Everyone can see my screen? Is it okay? Okay, great. Because I'm not sure that the full screen is working there. Okay, so doing a keynote for security is a bit unusual, but in this day, I think Pauline and I, we decided to do a keynote, not really about security, but on how to build better open source projects. So how everything started. It's basically due to the lockdown and the pandemic part. So we had this discussion. So we both work on this project and various projects. And initially we're like, okay, so we should do some work on open source project. And we had this kind of obscure open source natural language processing project. Should we work on it and so on? But we were facing a kind of dilemma. And because we were like, it's a pandemic, we need to do something about it, and we need to even work for us and so on. And we say, okay, maybe we should do close face mask. And that's basically where everything started. We started to do face mask, and there's something interesting too. So what we have seen when doing that, we see a lot of similarities with open source projects, especially rules, practices, and so on. And we did learn a lot of things. Even if we are strongly engaged in open source development and so on, we basically discover a lot of things due to the fact of a lot of people doing face mask. So we started a project called Myanmar project. It's a funny name, so I think this name came like very late in the evening. I don't remember exactly the time, but I think Pauline remembers the times exactly. But it was like yeah, something like that, yeah. And we basically had this idea of contracting a Chinese word for Myanmar, which was like face mask, and this kind of IKEA style things. And we have this Myanmar project. So you can go to the website, you can go to the GitHub project and have a look at it. So we basically started that project. And we discovered by doing so that a lot of new things popping up, like rules, things about open source projects that we knew about, and stuff that were new and so on. And we wanted to share with you today our discoveries, maybe at the end, when you build a new open source project in the security field, to basically follow those rules. And we failed too. So we won't keep with, and we will not give you golden rules, but we found some interesting aspect there. So I think one of the most important thing, and then this one was like, I think for us a bit of a challenge, but we discovered that one. So your project has to resonate and be human. So it sounds like a bit like, philosophical and so on, but it's really simple. And simple facts. I mean, Pauline has a very small nose and I have a big nose. So it's simple fact. If you design face mask, people with big nose might have problem with mask design for people with small nose. Makes sense. So, and that's the thing is, and it's valid for open source projects too, you need users. If you don't have users, you cannot design your software, you cannot design your face mask, you are into problems. So, and going back to the roots of open source project, if you remember Eric Raymond, for maybe the old guys like Christophe and so on, that are very old guys, remember all those document and report where he has this famous document called the Cathedral and the Bazaar, where he explained that you basically have users. You need users. If you don't have users, basically you are not doing something right. And that's exactly the same with face mask. And what we decided to do is to be our first users. Pauline required some masks for going to the shop. I required some masks for going outside too. So we designed our own mask. And we were our first user. So this mantra is super important. Eating your own dog food is super important, and we have seen that with other projects. I mean, we had some success in some open source projects like MIS project and so on, because we were using the software and developing the software at the same time. But if you basically design without thinking about the users, I think you are prone to fail. And that's really one of the things. And we have seen that with the face mask project too. Second thing that we have seen is don't be afraid to try new things and learn from scratch. For example, if you look at open source project, a lot of people say, oh, you know, I don't want to contribute to open source project. I don't know how to code and so on. Same with face mask. For us, we had no fucking clue about sewing. We had no fucking clue about filter of textile and fabrics. If I remember, I was like digging into documents about like what is the best textile. I discovered about jersey, cotton, polycotton, and so on that didn't know about it. So for me, it was like digging into it and starting to reach it, and was quite interesting. And the thing that we did from the early beginning is like keeping a trace of everything we did. You saw the picture there. It's basically the folder of Pauline with all the experiments she did for all the different face masks and the different fabrics and so on. So it was like kind of Git logs of everything that has been done. And it was like a very important thing. And the thing that is interesting is how we started to design face mask. It was like, okay, we go on the internet and we go on Google, search for face mask design. And the first thing that you'll see is YouTube. YouTube, you have tons of face mask design things. It's very interesting and so on, but which one to start with? Which one to pick? It's super tough. If I remember correctly, we have seen like thousands and thousands of videos from Asia, from Thailand, from South Africa, North America, Brazil, and so on. All different videos, different language, with something funky cultural background and so on. But at the end, you have to pick a video and try. And that's we did. We basically pick a video and make a test. And you see all those experiments are basically all those different models. And that's quite interesting because when you pick a video on YouTube, you don't need to pick it by basically like selecting all those 4,000 or 5,000 videos. You basically pick the one that Google choose for you. So you basically have a bias that's coming from the YouTube recommendation algorithm that you get this data from them and you don't know why you propose that one, but that's maybe a completely biased one. But that's, you know, you have to deal with that. So and that's something that we have seen is video is nice to replay and basically have a basic trainings for makers, but there is documentation missing. And that's where we were trying to fill the gap. It's like from the video itself, we try out, document the failures, success, and publish it. And that was the Maemo project. It's really that. It's like publishing what we basically did, where we failed, and you see that we have a lot of iterations. And that's the interesting part. And I think for open source project, it's exactly the same. But again, if you do open source project, don't hesitate to publish about your failures. I know a lot of people want to have a clean GitHub repository with all the things that are perfect and so on. It's like for academia, it's always better if you are publishing your failures. So let's try and don't be afraid to show off things that failed and so on. Another thing is tooling. What you can see on the slide, we are using BBB for the chat. So Pauline and I were using it on a daily basis for discussing the project and so on. We were sharing screen. So we had all those issues with like no sound not basically synchronized. Okay, we were not using Zoom. So I mean, maybe why, but we were sharing screen using, for example, in this case, Inkscape for designing the logo, the tutorials and so on. It was really the thing. So the tooling aspect is super important. It's really, you basically take back the control of things that you are producing and you become really producer of the things. Just to go back to some theory, if you have time and you want to dig into that, there's a very interesting aspect, which is really the background of open source project and free software. Is the book from Ivan Illich, Tools for Conviviality. It was published in the 73, so I was not even born at that time. Maybe Christoph was, I think. But that's something that is quite important there. It's really the background of why people have to have the tools that are accessible for them. They can control the tools themselves, and they can basically have an equal access. And the thing, for example, with sewing machine and so on, is really that. If you can dismantle them, basically get one, understand how it works, and so on, is really this kind of process. And you see that you become part of the actions, and you become part of the action of creating your own tools. And that's really interesting. A small pity that we have seen during all those discussions about face mask design is a lot of things that were shared on platforms that were super accessible, but not always open source. For example, we have seen a lot of people using Google Docs. Super easy. They drop the pictures, the step-by-step guides of how to do the mask and so on. But it's easy, it's simple for them. So it's, I think, something to keep in mind for the open source project that you're working on. Make it as easy as possible because you may get more users. Another thing that we have seen that is quite funky too, and I think it's linked to different things. Yes, and I think we had this discussion with Pauline a lot regarding what is really the trigger of people basically sharing and so on, and what are the things that are helping them for sharing. Obviously, time constraint. So we have this discussion about what is time. It's really urgent. We need to have those masks. So we don't really care about intellectual property rights. And you see that those rights usually add viscosity, add complexity, and so on. In this case, we had a lot of flexibility of creative exchange and so on, just by the fact of timing constraint. Another thing was like the social pressures. I mean, everyone wants to go in the same directions, protecting people and so on, and that's really helping. Another thing that we have seen is every work we did for the past 25 years on licensing and so on, and maybe some people in the audience know about that, but there's a lot of existing framework for licensing. The Free Software Foundation did some, the Open Source Software Initiative did some, and the Creative Commons Initiative. There are some others, but those ones are really helping everyone. So a lot of people were just like GitHub selecting a license, that's it. They didn't even care about the license they were choosing and so on. But the most funny part is a lot of people that were designing closed face mask designer didn't even know they were doing open source. They were doing open source without knowing it. And that's another thing that is quite interesting too, is there's a huge amount of people that could collaborate to your open source project. They just need to be informed about what is open source and what is the community behind, what is the goal of it. Another thing that is really important is if you build a project, you need to reinforce social relationship. During, obviously, lockdown, it was a bit harsh and difficult for a lot of people. So I think fun and funny project is important. So on the left side, you can see some screenshots. Those one are the less sensitive one. We see, for example, Pauline having a huge bowl of miso soup. She's converting sometimes close mask into bra. So, but that's personal matter. So everything is fine. So it's really important. It's sharing and giving back to the community and keeping it fun. Something I discovered personally that's quite interesting too. A lot of open source people were like part-time open source contributor. They're working at the office, come back at home, doing some contributions. But now we were all in the same boat, all having to contribute 100% into open source projects. And that was quite interesting because we were all facing the same problem that some contributors that I knew about were like, oh, remote working is painful, and we're like, oh, yes, it's not painful. But at the end, we discovered it was like painful and difficult. So it's really important that we really rely on those capabilities and people that already know about 100% remote to manage those communities. And I really advise, and it's not because the guy is Belgian, but I really advise to read a book from Peter Hitchens called Social Architecture Building Online Communities. He explained from the ZeroMQ communities how to deal with the open source communities is super important. So if you start an open source project in security, read that book. It's really cool. It's explaining to you how to deal with contributors, even difficult contributors, and so on. And that's really, really interesting. Again, fun is super important. You see that you can jump into a box when you are remotely. No one has been hurt. No cats has been involved here, but you see it can be fun. Another thing that it's very important is to cultivate your open source project. And the only way to do that is some people will say the GIF community, some people call it reciprocity or economy, but reciprocity is very important. If you start to have people creating issues, pull requests and so on, if you reply back to them, it will dynamize and cultivate your first projects. It's super important. And at the end, when you share the same tools, and you see, I'm going back to the tools are super important. You don't exactly know that, but sometimes when you, for example, do gardening, you do aren't, and so on, you really rely on your tools. And that's the same for free software. If you share tooling for supporting your tools and so on, it's really helping the community and it's creating value for everyone. Obviously, when you start to create an open source project, you create knowledge. For example, Philippe, that is part of the PassSol team, has a super wiki. Every time you search something for RFID, boom, you end up on his wiki. Because he is basically putting his knowledge into a wiki, he's documenting it, and is indexed by Google. And that's really important. And that, for example, if you find a bug fixes on an open source project that the guy doesn't want to fix, he will add it a patch on his wiki. That's cool. So that's every contributor should do. And that's another thing that is quite important too for face mask. For example, we have seen that diversity is important because people have different faces, they have different requirements. I mean, someone working full-time in a shop has different requirements than someone just traveling by the subway to go somewhere and just having a face mask for 30 minutes. So that's things that if you have more people, more users, and more contributors, you can basically cultivate your project on the long term. That's quite important. During the project, we were using a lot of open source projects, but I just want to list some of them that we were using. This one is my, I would say, frustration and complaint about a French agency. I use Pythons quite a lot, especially for extracting a large table of filtering tests. So the organization was sharing a PDF, and this PDF was generated from Excel. So I asked them to share the Excel and say, we are not allowed to share the Excel. So you end up by using Python to extract that. It was useful, but at the end, you see, sometimes you have to find a way to extract that. A lot of things that were interesting too is Science Hub, which is not per se an open source project, but it's basically a door to paywall and basically it's breaking paywalls, was for us very important because we were able to access academic papers doing tests and filtering on textile fabrics, which is a very important method when you build masks. Which textile to use, which one is basically more filtering, which one are filtering viruses, or one bacteria, and so on. Another thing that we want to thank everyone to is basically the people that did face masks during those days, because they were part of the community without even knowing it. And that's quite important too. Sometimes when you do open source software, you don't know that in advance. So what we can say after those months of project, we say that we succeed in some way. I mean, open source and maker communities resonated much more than usual. During the crisis, a lot of initiatives started, supporting hospitals, local communities, people, and so on, even your neighbors, and so on. So it was really quite successful. We have seen that a lot of open source things that has been done in the past was useful. The licensing aspect and so on, all those hardware licensing and so on, make a lot of sense. All people doing 3D printings, licensing, and so on, make a lot of sense. We have seen a lot of people using Git for supporting their coordination effort and for content publishing. We see that more and more. So that's where we succeed. But we fail too. Still, some open source tools are super complex to use. I mean, people uploading video on YouTube is an example. I mean, for them, it's super easy. They upload a video and that's it. But we have no, for example, good open source tools for editing, commenting videos and to mix match those two, video and content. Because sometimes when you want to, for example, make a mask and you look at a video, you want to pause it and to really understand, okay, what the people behind it is, for example, is this return part? Is it the mask up front? Where do you want to use it? And sometimes you have to stop and there's no explanation. And then you have to go back to the video to see the previous one. Did he swap the mask afterward and so on? So we really need some stuff in that area. Another thing that I think Ange Albertini will be very happy with that. He did a talk some years ago, I don't know if it's 2 years ago at AKLU, about the fact of we are really bad at archiving what we produce. And I think he was right. And we are still very bad. If you look on GitHub right now, all the face mask design, 3D printing and so on, you have hundreds of them. Some have no README, no text, no explanations, just a drop of files. They have no labels, no classification and so on. So there's a lot of work as a kind of librarians for open source where you have to index, evaluate, for example, evaluating all the face mask design, which one is good, which one is bad, which one is more for European faces, one for the Asian faces and so on. So in coordinating all of those. And when doing the project, we fail literally on something very important. I think all in the software community and open source community know about this mantra: release early, release often. I was like knowing about it, and I super failed about it. Why? Because the thing is, masks, we were needing them at really very fast way, and we were like polishing the website and so on, and saying, okay, 2 weeks or 3 weeks is fine. No, we should have released it as first day. Even it was like draft super early, we should have done that. And I think, again, we failed on that one, even if you knew it for years. I think for my side, I know it for more than 20 years, but I failed. So that's the thing. Another thing is there we have plenty of opportunity for new open source project. One, and you have seen that during in the presentation and the slide that I have here, I have a lot of screenshots of BBB. That's great, but the thing is, I want to stop my markdown at the same time and doing the context with the video and so on. So there are plenty of opportunities for new open source project, and I would dream to have an open source project where you can do notes taking markdown, stop, screenshot what you have seen on a video chat and so on, and you can see directly what has been done there. So that's it for the keynote. So you see that this project, which was like nothing to do with the directly open source, for us was like a kind of trigger, say, okay, we are still badly documenting how we do open source project. And that's where we want to go there. Pauline is working on a document that we will publish afterwards, describing what we discover, at least from our side. We have some bibliography, and I think if you have time to read those, have a look at those one, and I would really advise you to read the fourth one about social architecture, especially if you have an open source repository and you maintain and deal with contributors. It's really insightful. So now if you have any questions, either Pauline or myself can answer those questions. Thank you.
Thank you very much.
Okay.
Effectively, we have got some Q&A possible. So if you have got, we have got 3 minutes to ask question more directly to Alexandre and Pauline. And after, if you remind them, you can ask some question on Freenode. Maybe have you got a first question, Philippe?
Yeah, I can start as there is nothing in the pipeline. You mentioned quickly my wiki, thank you. But actually, I was facing a more security issue with that. Some years ago, it was very easy to make open platforms, open for edition to everybody and get everyone collaborating on one. But today, I take my wiki as an example. It's just impossible to even leave registration on without a massive CAPTCHA. So how today can you make such open platforms very easy and open for contribution and avoid these bots?
Pauline, you want to answer or should
I think so. It's something we discussed before, that there are huge needs for platforms that can manage at time that we need to be efficient in collaboration, and also we need to have good rule of privacy and to protect our data. And it can be more sensitive if you go on different projects. I have no answer yet. I don't know for Alex, if you got any ideas of things that have been done previously.
Yeah, the thing is, it's a kind of a pity, but what I will say might I think, raise some hand there. But for what I've seen is some that are successful, like Wiki like that, have this kind of authentication against Google. So instead of using a CAPTCHA, they use centralized single sign-on, again, existing like GitHub services and so on. So the only one, for example, I'm thinking of HackMD and some others like that, you register with your GitHub account and you basically just start to contribute and so on. So that's one way of avoiding like spamming and so on, because those accounts are registered and known. But I don't favor it for a matter of privacy and so on, because you basically get the tracking services from your providers and so on. So I think Philippe has a very interesting point, but to be honest, I still don't know exactly how to solve it. But that's maybe an interesting project too, there, to ease self-registrations and contributions without having spammer, or at least less spammer. I think Wikipedia is facing the same kind of problems too, and some others. But that's, in my experience on that, I don't see a direct like functionality or idea that could solve this issue.
Thank you.
Thank you. No, it seems no more question in the pipeline Q&A. So thank you very much for this keynote, Pauline and Alexandre. And now we are going to start our first session dedicated to more security identity. We are going to start with Niels Amiet from Kudelski Security, speaking about FIDO2. Welcome, Niels, and the stage is yours.
Thank you. So I'm going to share my screen. I believe you need to stop sharing for me to be able to share.
Yeah, it is done.
Thank you. All right. Can you see my slides?
It's okay.
Yeah, that's good.
Thank you. Okay, so hi everyone. Today I will be talking about replacing passwords with FIDO2. My name is Niels and I'm on the research team at Kudelski Security. I don't need to tell you that passwords are a problem. Many big players in the industry and probably anyone that's ever used a password knows there are many problems with those. So is there a way we can actually do better? Enters FIDO2, a new specification that was developed by the FIDO Alliance. And it is actually the combination of two specifications. The first being web authentication or WebAuthn, and the second is the client to authenticator protocol or CTAP. And the combination of these two specifications aim to address multiple use cases in authentication or login. The first one is one that completely gets rid of passwords. So it's a passwordless authentication. You can also do what they call multi-factor authentication. That means passwordless plus another factor such as a PIN or a fingerprint or your face, let's say a biometric. And finally, the last use case is you can also do the regular username and password login, plus an additional second factor, such as, let's say, a security key that you possess. Previously, that was done with the U2F, Universal Second Factor Standard, and in FIDO2, that was renamed to CTAP1, and it's completely backwards compatible with the old standard. So in FIDO2, you have three main actors. The first one is the client. That's the device that you use. It has a web browser that can be your laptop or your smartphone. The second is what they call the relying party, or the RP, and that is the server that wants to authenticate you. And finally, there is a device that the client uses that's called the authenticator, and that's what the client uses to prove who they are. So there's two specifications, but what are their purpose? So the first one, WebAuthn, is actually made for web browsers. So it's a JavaScript API. But the client to authenticator protocol is a way for clients to communicate with authenticator devices. That's basically a way to have a standard for communicating with those devices. And when the client communicates with an authenticator, it will send messages that are encoded in a format called CBOR. And one difference here is that the CTAP protocol is actually not just for web browsers. So it also works with desktop and, let's say, command line apps, unlike WebAuthn. We mentioned authenticators. There's actually two different types of authenticators. The first one is platform authenticators. So that means the authenticator is permanently attached to the client device, so it cannot be removed. For example, your smartphone or your laptop is the authenticator itself. The second type of authenticator is a roaming authenticator, and that one is not permanently attached. So that means you can plug it into multiple devices. For example, either using USB or NFC or also Bluetooth, but that's less common for those authenticators. There are many different vendors of such authenticators. If you are into open source, there is one which is called a SoloKey, and the firmware is open source. And there is also something worth mentioning, the OpenSK or Open Security Project, that is a Rust implementation of a FIDO2 authenticator. If you want to get one of those roaming authenticators, they are pretty cheap, and you can get one for roughly $20 US. Here you have a few examples of those authenticators, and you can notice that the two on the bottom right are actually platform authenticators. All right, so how does it work actually? Well, there are two flows here. The first one is registration. The second one is authentication or login. So the relying party will actually serve a registration page to the client, and that page includes some JavaScript code. This code will execute when the user clicks the register button. And in that code, there is a call to a function that's defined in the WebAuthn JavaScript API. And that function is implemented by the web browser, and it will call the authenticator device. The authenticator device will perform a few checks. The first one is the user presence check. So it will simply check that the user is physically here, so that it cannot be faked doing like a remote attack. And optionally, it will also try to verify that the user is actually the owner of the authenticator. If that works, then the authenticator generates a scoped key pair. So that means that key pair is generated for that specific website or RP, and it can only be used with that specific RP in future logins. And that completely eliminates phishing attacks. The private key is stored on the authenticator, and the corresponding public key and an attestation signature, we will see what that is soon, is returned. That goes back to the client device, which forwards it to the RP. The RP can verify the attestation signature and stores the public key so that it can use it in the future to authenticate the user. Now in the authentication or login flow, similarly, the RP serves a sign-in page that also contains JavaScript code, which executes when the user clicks the sign-in button. And it will do a similar call to one of the methods in the web authentication API, which calls the authenticator, does the user presence and user verification checks. If that works, it returns not an attestation, but an assertion signature that's produced using the private key that we generated in the registration step. That is returned to the client's device. It is forwarded to the RP, which can verify that assertion signature using the public key that it stored during registration. And if that works, the user is successfully authenticated. So what are the main responsibilities for the three actors? So first, the authenticator device, it has to perform the user presence check to check that the user is physically there. Usually the user does that by simply tapping the authenticator to prove that he's physically present. Optionally, if the authenticator device supports it, it will also perform a user verification check, either by using a PIN that the user must know and have set before, or a biometric fingerprint or face. Also note that these checks are done client side, so on the authenticator and not on the RP. And we will see how the RP can trust those that those checks were done soon. The authenticator generates and stores the credentials, and it produces two types of signatures: attestations during registration and assertions during authentication or login. Now the client, it simply acts as a proxy between the authenticator and the RP, but it may do a few other small things. Imagine if you have multiple accounts on a same website and your authenticator device does not have a built-in screen, then it's the responsibility of the client device to display an account selection dialog, let's say. And finally, the RP, it will verify both types of signatures. It will check that the parameters passed in the first place match what he receives in the end. It will store the public keys. It generates and verifies a random challenge to prevent replay attacks. And it makes a decision whether it wants to authenticate the user or not. And we will see how that is made. So we mentioned attestations and assertions, but first attestations, why do we need them? So that is a way for the relying party to actually trust the authenticator device and to be sure that the data that's produced or returned by the authenticator really comes from that specific model of authenticator and that it's not a fake one. That is achieved because there is a pre-established chain of trust. And if the RP trusts the authenticator device, then it can verify what's the security level of that specific device and know some characteristics about that device and actually make a decision based on those characteristics. That also means that, for example, the user verification check that is done client side, if it's done, the authenticator will set a flag in the response and say that the user verification check was performed. So if the RP trusts that data, it means it is pretty sure that the check was done client side for real. We need to know that those attestations are actually optional, but it is very recommended to implement them. And those attestations are created, as I said, during registration. And the signature is computed over the concatenation of two things. The first one is the authenticator data, and the second is a hash of the client data. The authenticator data contains the public key that was generated, a unique ID for that authenticator device model, and flags such as whether user presence checks or user verification checks were performed, and a few other things. And the client data contains the challenge that is used to prevent replay attacks, and the server origin, so the domain name of the RP, plus a few other things. These attestations can be of different types, and if you choose a different attestation type, there is a different trust model associated to it. These types are the ones that are defined in the spec. So there is basic attestation, self-attestation, ATTCA, ECDAA is elliptic curved based direct anonymous attestations, and you can also say none. So that means you don't want to use attestations at all. We will only go through the first two types because the other two are actually more difficult to implement securely and less used in practice. So first, basic attestations. So how does it work? So basically, an attestation private key is burnt in at factory, and the corresponding public key is bundled in a certificate, and that certificate is part of a chain of trust of certificates, and so that we can establish a common root of trust, and so that the RP can check those signatures that are produced with that attestation private key. If we were to put the same private attestation key in, if we were to put different private attestation keys for each device that is produced, each authenticator, we would have a privacy problem here. Because imagine if you have multiple RPs that talk to each other, they could actually track the users because they have each a different public key. So to avoid that, it's recommended to have a batch of authenticator devices of the same model that share the same attestation private key, so that you have a good compromise between privacy and impact in case that attestation private key is leaked. So about that leak, what could happen if the attestation private key is compromised? Well, it would mean that the RP is not able anymore to distinguish between a true, let's say a true YubiKey5, which is a specific model of authenticators, and a fake one that I could have built myself and that uses that leaked private key. So you cannot guarantee anymore that there's no, let's say, backdoor that accepts any PIN inside of that modified device. The other type of attestation is self-attestation. So that one, it will produce the signature using the private key that's generated during registration. So it's a bit like self-signed certificates. And that means it proves nothing about if the authenticator is really the model it claims to be. So what's the best attestation type? So I know we did not go through ATTCA and ECDAA, but on paper, ECDAA looks like the one that would provide the best features and security, but it's really difficult, I would say, to implement securely. And in practice, not everyone is going to need that security level. So you may just see people using basic attestation or not using attestations at all. And I think it does not make sense to use the more complex attestation types if your authenticator device does not have, let's say, basic protections against glitching attacks. So the other type of signature after attestations is assertions. So the assertion signature is the one that's produced during authentication or sign-in. And unlike the attestation, it is produced using the private key that is generated during registration. And the RP verifies it using the corresponding public key. It's also computed over the same data, the authenticator data and the hash of the client data. But one difference here is that it is possible to use different public key algorithms with assertions. So a quick overview of the APIs. So first, WebAuthn. There are two main methods that you should use here. So there is the create method and the get method. You can use the create method in your JavaScript code if you want to request the authenticator to create a new key pair for registration. When that method is called, it will, behind the scenes, make a call to the authenticator and request it to produce that key pair. It will return the public key and the attestation. The other method, the get method, is the one you use if you want to get an assertion signature that will be produced by the authenticator using the private key that was generated before with the create method. WebAuthn supports a few extensions. It's just something that's good to know. One use case where you could need extensions is, let's say you are implementing the RP and you want to make your decision based on how the user was verified. So you want to know which method the authenticator used to verify the user, like what did he ask the user to input a PIN, or did he check his fingerprint, did he check his face, and so on. On the other side, so you have the CTAP2 specification, and it also has those two main methods that are corresponding to the WebAuthn methods. So when you call WebAuthn create, it will call make credential on the authenticator. And when you call WebAuthn get, it will call get assertion on the authenticator. CTAP also offers a few other operations. You can get some info about the authenticator that's connected. You can manage the PIN. You can completely reset the device, removing all the keys that were generated. And CTAP currently is in CTAP 2.0. That's the latest stable version. But there is a draft specification that is soon going into stable that is going to add two more commands. The first is a way for the user to manage let's say the fingerprints, if you want to add a fingerprint or remove one from the authenticator. And another command is for managing the credentials. So you could say, I want to know how many keys were generated on my device, or I want to remove a key pair from the device. There is also a range of commands that are reserved for vendors so that they can implement custom commands. And like WebAuthn, CTAP also offers extensions, but at the moment there is only one that is defined in the spec, the HMAC secret extension. One way you could use that is you could implement a password manager. That's something I've done. And that extension allows you to derive a secret from a private key that you generated on your authenticator. So you could use that secret to symmetrically encrypt or decrypt your secrets. Another thing that is used in FIDO2, that's the FIDO Metadata Service, or the MDS. So what is it? It's a public database where vendors can publish information about their authenticator product, such as some characteristics about it and like that defined how secure it is, or some features that it supports. The RPs should regularly download all of that info from the MDS so that they can build a local list of characteristics about those existing products, and so that they can take a decision when someone logs in with such a device. Otherwise, then as an RP, you don't know anything about that device. You don't know its characteristics. Also, another thing that you can know from the MDS is, for example, we talked about basic attestations, and there are those attestation private keys. If that key is compromised, then the vendor would publish a status update to the MDS to let users know that that specific model has been compromised, and then RPs can take a decision if such a device is used. All of that data in the MDS cannot directly be accessed, so you must request an access token, which needs to be renewed yearly to download that data. What exactly can you get from there? So if you download that data, you get a list of those devices. You get the unique ID of the device. You get the list of status reports, like is it fine? Was the attestation private key compromised? And you get a link to download more info about that specific device. When you download that, you will get the name of the device, a short description, just some text, and you will get the attestation root certificates. So that's one of the important parts, I would say. So this is how the RP can establish that root of trust that we talked about before. You can also know like what methods does the authenticator support for verifying the user? Like, does it have a fingerprint reader on it? Does it support pins? Does it recognize faces? I don't know, does it have a camera? It will also tell you like how the keys are stored on the authenticator. Are they stored on TPM, for example? You're also gonna get some info, the overall cryptographic strengths of the device. So that's just a number that kind of summarizes how secure the device is. You should not use just that number, but you should definitely look at the other characteristics as well. And you also get a list of the supported public key algorithms supported by that device, plus a few other characteristics that you can look up in the spec. So what about security measures that are implemented in FIDO2? There is one thing in the CTAP specification. Actually, the authenticators should implement a counter that increases every time the user wants to get an assertion signature, so every time they want to log in. And that counter is sent to the RP. The RP must save that counter value. And if an attacker, let's say, clones the authenticator device, then those two counters will start to diverge. And at some point, if they are used for login, the RP will see that the counter is not always increasing. So if that happens, the RP knows that something wrong is going on, and it may take a decision like just notifying the user or not accepting login. There is also a maximum number of failed PIN attempts that you can do if you use the PIN. If you fail the PIN too many times, the maximum is 8 times, then the authenticator is completely locked and you must reset it. And that means you lose all the keys that were generated on the device. To prevent an attacker from making malicious failed PIN attempts, there is a a protection here, and if the pin is failed 3 times, then you must remove the device, like disconnect it and replug it, so that you prove that you are physically present there. The keys that are generated are scoped to an RP. So that means if you register, you generate a key pair, it's only valid for that site. It cannot be used on other sites. And that completely removes all phishing attacks. And finally, you also get physical theft protection if you use multi-factor authentication. So if you also set a PIN or a biometric on your authenticator. Another thing that is possible to integrate with FIDO2 is token binding. So if you've never heard of token binding, that's defined in an RFC. And it's a way to prevent session hijacking. So imagine you have a secret, such as your session cookie or, I don't know, an OAuth token. You can bind it to a specific TLS connection so that even if an attacker steals your session cookie, it will not be able to use it because he will connect with another TLS connection and the server will see that something wrong is going on. In practice, that's not used because web browsers do not support it. Edge used to support it and Chrome as well, but in the latest version of Edge, they moved to the Chrome engine and Chrome also dropped support. So it's very limited at this point. If you are going to use it, you just need to know that the token binding ID can be specified in the client data in FIDO2. So how is FIDO2 being adopted at the moment? For the passwordless use case, there is only Microsoft.com accounts that I know of that implement FIDO2 passwordless login. And you must set your user agent to Edge on Windows for them to even display you the option to sign in using FIDO2 passwordless. So hopefully you implement it and your site enlarges this list. And if you are going to implement FIDO2 passwordless on your website, please let your users know that you support it by using one of those IMARC logos and putting them on the login form. For the 2FA use case, there's many sites that support it, and previously with U2F, many websites implemented it. And it's pretty easy to move from U2F to WebAuthn because it's backwards compatible in the second factor use case. For CTAP only, I know of OpenSSH that added in version 8.2 a way for you to generate an SSH key that is stored on a FIDO2 compatible device. WebAuthn is supported on all major web browsers on desktop and mobile. And CTAP2 can be used using the regular transport channels, USB, NFC, Lightning. If you have an iPhone, you will need an iPhone 7 or later if you are going to use NFC. And on desktop, USB is your best bet. A few examples of platform authenticators that exist already today. So if you have a MacBook, let's say, with a touch bar and that has Touch ID, that is a platform FIDO2 authenticator. That's all you need. If you have an Android 7 Plus smartphone, it is a FIDO2 authenticator. And if you have a Windows machine with Windows Hello configured, that is a FIDO2 platform authenticator as well. Soon in iOS 14 and macOS Big Sur that were recently announced, they will also add that feature, and any devices running those OSs will be FIDO2 platform authenticators as well. If you're going to implement it, there are many existing libraries, both for client side. So if you just want to do CTAP to the authenticator, or server side, if you want to implement an RP. You should definitely pull entries from the MDS to build that list of characteristics locally and build your trust store. And do not blacklist vendors. So it's not a good idea to say, oh, you're not using a YubiKey. Well, I don't want to accept that login. You should really look at the actual characteristics. So is the password problem solved? Well, you don't need to choose, remember, or change passwords anymore. The protocol prevents password reuse because it generates a new key pair for every account and every website. It's completely invulnerable to phishing, and it's a strong protection against network attacks. So it makes a pretty strong case here, I believe. A few takeaways. So you should always register a backup authenticator so that if you lose it, it gets stolen, it breaks, you are not locked out of your account, you still have another one to log in, and you can revoke the other authenticator. You should also make sure to set a PIN or a biometric on your authenticator to prevent theft attacks. You could tell me, but you're just replacing the password with a PIN, but that is not true because the password is sent over the network and is vulnerable to all network attacks. And the PIN is local. It doesn't need to be changed as often. It cannot be brute forced. If you still don't like PINs, you can still use a biometric instead. So FIDO2 is still young. CTAP 2.1 is on the way. There's few websites that implement the passwordless scenario at the moment. So please add support for it and use attestations if possible. If you'd like to learn more about this, I wrote a blog post series on the Kudelski security research blog. There is a live demo on webauthn.io that you can use to test, let's say, with your Android phone that's in your pocket. If you just want a quick intro to FIDO2, you can go to loginwithfido2.com and it will explain the basics really well. For more info, there's the last two links, and otherwise you can still refer to the official WebAuthn and CTAP specifications. Thank you, and the floor is open for questions.
Thank you very much. We have got time for one or two questions, and effectively we have two questions in the Q&A. So just read it, and if you can answer, Niels, there you go.
Okay, so the first question is big tech companies such as Google, Facebook, and so on are pushing this specification. Do you think that it's going to get traction from the mainstream websites, public and private sector? So I would say, I hope so. Microsoft already implemented it for Microsoft.com accounts, and it's still young, but I think starting from this year, we've seen support for more and more platforms. And I believe by the end of the year, it's just going to work out of the box on kind of all mainstream devices. So we just need more developers to implement it, basically. So support is here. So we just need to see whether developers want to support it or not, or if they think the users will benefit from it. There is another question. Okay, so the question is, does OpenSSH really support FIDO2? I thought it only supported FIDO U2F, not FIDO2. So yes, but it only supports the CTAP2 part. So basically, it will allow you to generate an SSH key, and that SSH key is actually implemented as a private key that's generated on the FIDO2 authenticator. And when you want to log in, you will need to plug in your FIDO2 authenticator or use a platform authenticator if you have one to log in using that SSH key. So yes, it does support the CTAP2 authenticators.
Perfect. And we have got a last question. So just mark them answer live, please, Niels. So they will disappear. Thank you.
So the last question is, what are main evolutions between CTAP 1 and CTAP 2.1? So basically, CTAP 1 is just U2F renamed. So in CTAP 2, you have a new format that is used. So the messages are encoded in CBOR, but previously it was another binary format that was used in U2F. And in CTAP 2.0 and CTAP 2.1, you have more operations that can be performed. So the spec is quite different, actually.
Perfect. Perfect on time, Niels. So the goal is reached. Thank you very much for this talk.
Thank you.
And now we are going to switch to our second talk in this secure identity track. We are going to welcome Clément, not for the concert first. We have got a technical talk about understanding management of password policy under OpenLDAP. So, Clément, the stage is yours. Thank you very much for coming.
Yes, thank you. Hope you hear me and you see the slide. It's all okay?
Yeah,
Yes.
everything is okay.
Great. We just had a very nice talk about why passwords are a mess. Thank you. So my talk is about passwords. I really totally agree with the previous talk, but mine will try to give some help to people that still needs passwords and still need to manage them. And we will focus on password policy in OpenLDAP. So in OpenLDAP, which is an open source LDAP directory, you can do something to have a better control on user passwords. So a quick view on who am I. I work for a French company which is called Vortex. And when I work, I'm doing free software. So you can maybe see the list here. You have Lemon LDAP, LDAP Toolbox, LDAP Synchronization Connector, Fusion IAM, and W Suite. So mostly identity management softwares. And when I don't work, I'm doing music. So thanks, Christophe, for introducing the concert tomorrow. Hope some of you will be there for this. I'm also playing in a show on YouTube, and I'm doing theater improvisation. Let's be back to our subject, which is the password policy. Before talking about the implementation of the policy inside OpenLDAP, I will talk about the policy inside, about the standard of password policy standard. So it is in an EATF draft, very old, because the first version was published the last millennium. And the last version is more than 10 years ago and is still tagged as a draft, which means that it is not an official standard of EATF. But even if it is expired, this draft is used in many LDAP directories. So we consider it as a standard. These specifications cover many points. The first is how you design the control request and response. We will see this just after. And for people designing LDAP directories, the standard also defined the LDAP schema to use to store password policy configurations. it explains what are the operational attributes that needs to be used for password policy, and what are the steps to pass to process to password control. So you see there that we have two main operations in which the password policy is involved. The first one is the authentication. So we will act on password when a user submitted to authenticate. And the second operation is the password modification. So we will act on the password while the user wants to change it. So a little schema, you can see there that we have a client and a server. So the client is not the end user itself, of course, it is an LDAP client. The LDAP client is doing an LDAP operation. So as we just said, this operation can be an authentication operation, so LDAP bind, or it can be an modification, LDAP modify. And you do the operation as a client, and you set a control, an additional field, which is called an LDAP control. Without any value, you just say, okay, I'm the client and I want to apply the password policy control. And the server receives the operation. So the first things the server is doing is to answer to the operation. And then the server sees that the client knows how to handle password policy. So the server will be able to send back the control response. And as you can see, the control response is a complex structure with many flags and return values that will allow the LDAP client to have information about the password status of the user. If you don't have any password policy control, the LDAP client will only know if the password is good or bad, or if the password was accepted for modification or refused for modification. But without the control, the client will have no information why the authentication was of use or why the modification was of use. The goal of the password policy is to give some status, some information to the end user to know why the password was refused. So you can see, for example, you can refuse the authentication because your account is already locked. So even if you have the good password, because your account is locked, even using a good password, you will not be able to authenticate. So this is one of the examples of the password policy. What it is really done at authentication is the following. The first thing the server is checking is the expiration. So if you have a maximal age of your password on server side, the server will refuse to authenticate if your password is too old. So it means you will not be able to authenticate with your password, even if your password is a good password. Your account can also be locked. So it means an administrator could have locked your account because the administrator don't want that your account be active anymore, or maybe an attacker has tried too many times to use a password on your account and your account was locked. It's to prevent brute force attacks. So if your account is locked, you can't authenticate either. The third check is, are you forced to change your password after the authentication? So we'll be back on this because it's a complex use case. But when you authenticate to an LDAP server with password policy, the LDAP server can say, okay, your password is correct, but you are forced to change it. No. And the last thing is to send back some warnings. The possible warnings in password policy are the time before expiration. So it means, okay, your password is valid, but it will expire in 1 week, for example. And another thing are the authentication graces. So it's a specific feature of password policy an authentication grace is a way to be able to authenticate even if your password is expired. So as the first point, I said, okay, your password is too old, it is expired, you can't authenticate anymore. It's not perfectly true, because if your administrator allows, for example, 2 authentication graces, you can have an expired password and be able to authenticate 2 more times. The goal is to be able to change your password after the password expiration. And for modifications, it's very classical. So you can check the password size, the password minimal age. So you can be forced to your password can be refused because you change it in the last hour. So maybe your administrator wants not that you to be able to change the password every hour, for example. And third point is the password history. It means we can keep a list of your old password. Of course, they are hashed in the history, so we can keep the password history, so you are not able to reuse an old password that you already used. And the last point is the password complexity, but for this, the standard does not give any clue about what should be done by the server. It means that every LDAP directory can implement its own complexity check. So most of time, complexity checks are about lowercase, uppercase, digit, etc. So here's the standard, but how it really works in OpenLDAP. OpenLDAP has 2 major versions for now. The current major version is 2.4, which is the current version since 10 years now. And it implements the version 9 of the draft. And OpenLDAP team is currently working on the next major version, which is 2.5, and is including the latest version of the draft inside this new version. So for the moment, if you install OpenLDAP, you will only have the password policy features that are described in the version 9 of the password policy draft. What could you expect by switching to the new version? They added the maximum password size. So in the version 9, you can define the minimum password size. In the version 10, you can have the maximum password size. They introduce the authentication delay. It means that you will delay the authentication if you have some failure on the password. The idle time is a way to be able to compute the time before the last authentication on the account. So it means if your last authentication was the previous year, we can say that your account was not used anymore. And so if you come back 1 year later, you cannot authenticate with your account. And the validity period is also a new feature. You can directly put some dates, so a start date and end date in your user account to be able to say, okay, my account is created, but it is not yet valid, so the user cannot use it. How it is configured in OpenLDAP. So maybe some of you know that OpenLDAP can be configured with LDIF files. If you don't know it, so now you know. And you just load the overlay. The overlay is a simple module of OpenLDAP. So you just say, okay, I want to enable the password policy, and you have three configuration options. The first one is very important, is that you tell OpenLDAP to hash the password when it is modified, when it is sent to your directory. The second one is to enable locking. And the last is specific options that you just need to enable if you have some slave servers and master servers, if you are doing some replications and you want to forward all the password policy information from the consumers to the providers. You can have many password policies inside an LDAP directory. So each password policy is represented as an LDAP entry with a specific object class. You can add a specific object class, which is the password policy checker, to load a specific module to check the complexity. So if you need one of this module, the Adaptable project is shipping one, which is called PPM, Password Policy Module, which is a very good name for a password policy module. And this is an example of a password policy configuration. So you see there are a lot of parameters. The name of the parameters are very explicit. So I will not explain all, but you see that you can set password max age, which is in seconds. You can set the password max failure. Here you see it's 10, so it means that if you fail 10 times, your account will be locked. You can work on this parameter by adding the password failure count interval, which here it is 30 seconds. It means that you need to fail 10 times in 30 seconds to lock your account. If you fail 10 times, but in another period, your account will not be locked. And the lockout duration, it's also in seconds, so it's 600 seconds, 10 minutes here. It means that your account will be locked for 10 minutes, and after 10 minutes, you will be able to log in with your password. Your account will not be locked anymore. So you see that inside the password policy configuration, we mixed some parameters that are used to check the authentication step and some parameters like the password mean size or mean length or the password in story, which are used when you update your password in the LDAP directory. When your password policy is configured, you have some operational attributes inside each user entries, and these attributes allow you to know what is the status of the account of your user. So password policy subentry is a pointer to the active policy for this user. Password change time, the date when the password was changed. The account lock time, the date when the password was locked. The failure time, it's a list of failure. History is your history. Grace use time is the time when you use your authentication grace. And the password reset is the flag that will tell your user to update your password. A small word on a second overlay, which is LastBind, which you can install on OpenLDAP 2.4. This overlay is used to remember the last authentication date. So in the next major version, this will be included in the password policy overlay. So specific things that no one's tell you and you have to discover yourself. The first one is account locking. I just said that you have an attribute in your user entry, which is password account lock time, in which you have the date of the password lock. You can't trust really this attribute. You can't say that your account is locked because you have the attribute, because if the date is greater than the lock time and the lock duration, you still have the attribute in your user entry, but your account is not locked because the date is no more the one when your account is locked. The value of this attribute is only deleted on the next authentication. So until the user has no done any authentication on its entry, the attribute is still in the account, but maybe the account is not locked. And the second point is the password reset. If you ask your password to change the password at next connection, the authentication is still valid because you need to be able to authenticate to change the password. So if your application is only doing an authentication, this flag will be totally ignored by the application because the authentication is still valid. So to have a real use case with this, you need an application that will check this flag and ask the user to change the password after the authentication. So know you know. To conclude this presentation, I would like to introduce a small software that I wrote. It is named Service Desk. It's part of the LDAP Toolbox project. So the goal is to support your support because a lot of support team are busy with issues from users that have lost the password of, or if the user has an account locked, he don't know that the account is locked and he thinks the password is not the good one, etc. So the support team needs to know quickly what is the account status and how to solve the user issue. So this is quite a single page application. You search an account in the directory, and then you can see all the information of the user and all the status of the account. And you can test the current password. So you can take the user password and check if the password is valid. You can reset the password, and you can lock or unlock the account. So the support team has no other rights on the entry. The only thing it can do is to unlock or change the user password. So quick search. So all these features are in the current version. So the latest version is 0.3 and was released 2 hours ago. So it's a very fresh version. It was released this morning. So if you want more, some links here. And I don't know. I think I have some minutes just to show you the application here. So here is the application is my account. So I can check my account here. So my authentication succeeds, and you can see that my authentication date was updated. I can lock my password. So my password is now locked. And we can directly see that we have some failure here. And if I use the LDAP browser, I will find the same values inside the directory. But of course, it is not easy to be able to have this status with an LDAP browser. It is really easy to see it here. And of course, I can unlock the account here if I want, or if I need to lock the account but permanently, you see it, the account is locked, but for forever. And if you look at this, you will see there is the password account lock time that was set inside the entry. And if I unlock and refresh, the value was removed. So this is a very easy software, but it implements all the password policy logic from OpenLDAP, and it is now very easy to check this policy and to check the user account status with it. Okay, it's over. Thank you. Hope this was clear, and I can now answer questions if there are any.
Thank you very much, Clément.
Thank you.
Maybe one question I have heard
Yes, just a quick question. You hear me?
Yes.
Does the draft does the draft specify how the passwords should be stored by the OpenLDAP server or the LDAP server?
The specific, I don't understand the question. Where they should be stored?
I mean, no, how the passwords are stored in the server. I mean,
with which algorithm
or protected? Yeah.
Yeah, no, it is not defined in the draft. Each LDAP directory can use any hash algorithm that you want, and the password policy does not give any hint about which algorithm you should use. You can even store your password in clear text and apply a password policy on it. So it is not incompatible.
Okay, it's left to the administrator.
Yes. Exactly, it is left to the administrator.
Okay, thanks.
Okay, so thank you very much, Clément. I don't see any other question, so no other answer also. So thank you very much for this talk, and we remind everybody that you are going to provide us a concert at 5:15 tomorrow.
Yes.
So we are going to take a 10-minute pause, and before restarting our last track with a talk about free software, forensic, and remote forensic on cloud environment with Google security team and with Thomas and Theo. Have a good pause, and we will be back in 10 minutes. Thank you. Well, the song is over, so I think it is time to be back. And as said previously, we are going to start this new session with a new talk, a talk about forensic and investigation in a cloud environment with using free software. So please welcome Thomas and Theo. Thank you very much for coming.
Thanks for having us.
Yeah. The stage is yours.
All right, let me try to share my screen.
It is done.
It's working? Great, because
Yeah.
I can't see anything now.
Yeah, it's perfect.
All right, great. Excellent. Well, thanks everyone for having us today. Like Christophe said, we're going to talk about open source cloud forensics tools in different environments. We call this tool "All Your Cloud Are Belong." The talk "All Your Cloud Are Belonging to Us" because we felt it was funny. So these are going to be your hosts today: myself, Tom, and Theo, who is with me. We are both working in the DFIR team at Google. We do incident response and a lot of forensics engineering. We're both based in Zurich. So far, I'm the DF Time Wolf core developer. You may have heard of it in the past. It's a small tool. There will be a brief mention of it during this talk. And Theo is the mastermind behind libcloud forensics. And this is what this talk will be about. So why do we come up with libcloud forensics? Because we wanted to do some stuff in the cloud. And as we know, the cloud can be a very unwelcoming environment. So what were the motivations behind it? First of all, we needed to automate all our cloud investigations because Google being Google, we always have to work at scale with a lot of stuff that's going on. So automation is very important for us. In the same vein, we also wanted ready-to-use investigation environments. So whenever we had an incident that required us to investigate the cloud, we really wanted to have all the tools that we needed right there. Manually installing tools takes time. So we really wanted to have the process as streamlined as possible. And also, the cloud is cool because you can have big, beefy VMs in the cloud that are way faster than your workstation. So if you want to process forensics evidence there, then it's really good to have a very big computer in the cloud. Some caveats, though. We didn't want to reinvent the wheel or to be the Swiss Army knife of cloud. We only want to do one thing in cloud and do it well, which is doing forensics. So the library that we came up with, as we'll see later, has a very essential functionality and very few dependencies, but just what we need to do all the forensics in the cloud. This is why we came up with libcloud forensics. So basically, it's a Python library that allows you to interact with different cloud providers. So GCP, AWS, and Azure for now. It's very lightweight and it's very focused on forensics. So you can use it to do stuff like copying disks, kind of like a DD in the cloud, spinning up ready-to-use analysis VMs, and also grabbing all types of logs, whether it's on GCP, AWS, or Azure. There's a few similar projects that we saw when we started doing this, which is Apache libcloud, which doesn't have a focus on forensics and supports around 30 different types of cloud providers, which is a lot and way more than what we needed. And also for Steady Security, which is a security project also where Google has its collaboration. But it's focused on GCP and has a few of the primitives that we'll see later on, but it's not really focused on forensics itself. The main challenge that we had was to try to come up with a generic enough way to name things in our project so that it kind of makes sense in different cloud architectures. So for instance, what is a disk in GCP is going to be named a volume in AWS. So we had the choice. We could either try to come up with a common vocabulary or taxonomy that made sense across all clouds, or we could instead come up with a similar interface for different cloud providers, which is what we ended up doing. We didn't want to have, yet another competing standard of how to name things, and rather we stuck with what we knew. Anyways, this is enough about the intro. Let's dig into the deep code things with Theo. The screen is yours, I think.
Yeah, I can control it for now. Let's see again. Yes, awesome. It seems to be working. Great. So libclat forensics, in a nutshell, as Tom said, it's a Python 3 library. It comes packaged with a CLI, and it's very easy to install. So for those of you that are familiar with the pip environment, you can just pip install it very easily. Then provided that you have configured authentication with the different cloud providers, libclat forensics will just reuse that and transparently authenticates and interact with the different cloud providers. It's open source, so that's pretty cool. Under Apache 2 license, we will tell you a little more on that later on. Now, this is the library architecture that we came up with. So each provider has a module, and then under each of these modules, you will have a forensics.py file, which exposes higher level forensics functionality, such as creating disk copies, starting analysis VM. And they also all have an internal module, which is where we basically hide all of the cloud provider specific functioning. And we also expose primitives for each of these providers that are more internal, such as list instances, list disks, list logs, and so on and so forth. Now, let's see how this all works in GCP. So let's say we have the following scenario. We have a Google Cloud Engine instance hosting a content management system that gets owned. So we're going to be wanting a few things. First, we want a forensic copy of the compromised disks that belong to this instance. We also want an analysis VM that is ready to use so that we can forensicate the disk. And ideally, we want this in a separate project. We also probably want a coffee because this is going to be a long investigation. What we really don't want is to do any of these tasks manually because it's really cumbersome. So if you're familiar with GCP, if you wanted to do a disk copy in there, there are a few steps involved. You would first have to create a snapshot of the disk in the source project, and then you would have to create a new disk out of this snapshot in the second project. And then you have to, create your VM, connect to it, install all the tools you need, attach the disk copy that you just created, and then you have to bounce back to the first project and do some cleaning up because you don't want to have all these intermediate resources just laying around. So in this slide, you can see a snippet of code that's basically doing all we just said in just 2 function call. So in the first part of the code, you can see how you can create a disk copy in GCP. It should be noted that the parameters you see there are GCP specific, and that if you were to do the same in AWS or Azure, some of them might be different. For GCP, you have to specify the source project, which is the project in which you have your compromised instance. Then you will specify the destination project, which is the one you want to carry analysis on, the instance name, the zone in which this instance is, and then you have an optional disk name parameter, which is pretty useful if you want to investigate one disk in particular, or if you don't specify it, then we'll just grab the boot disk of the instance. So after this first function call, you already have your forensic copy in your analysis project. And then the second part of the code focuses on creating an analysis VM. So there again, you specify a bunch of parameters. The cool thing is that you have a lot of options to customize this VM. So you can choose the boot disk type, the size, the number of CPU cores. As Tom said, if you want a really beefy machine, that's pretty cool. But more importantly, you can specify a source image for the VM. So if you want to use Ubuntu or some other OS, that's up to you. And in particular, you can specify a path to a script that will be executed the first time the machine is boot up. So that's pretty useful if you have any pre-processing job to do on your VM before you start your investigation. Now, this is what you do in code, but libclat forensics also comes with a CLI tool. That's the in the slide you can see all the functions that we have in the CLI for GCP. Those are meant to be easy to use and ready to use, so that you don't have to write any code. So if we wanted to do exactly what we've done before, but with no code, this is what it would look like. So just two one-liners, one to do the copy of the disk, and want to do to start the analysis VM and get started?
Yeah, so as I mentioned before, TimeWolf is a very big user of this library because it interacts a lot with cloud. And TimeWolf is basically our forensics pipeline where we use it to make the link between all the different forensics tools that we have. In this case, this is a slide from a previous talk about how Greendale, this fake university, got compromised by attackers. And this is Cyber Forensics Assurances, the consulting company that comes in and helps them. So in green, you have the Greendale IoT Cloud project, and in blue, you have the incident response project. So a full pipeline usage of this library would look like something like this, where TimeWolf asks the Greendale project to copy the disk for Jenkins. The new copy is returned. This copy is sent to the response project, and an API call is made to Turbinia saying like, hey, Turbinia, can you please forensicate this for me? Turbinia is going to run Plazo or Log2Timeline on the disk image and store a Plazo file in a Google storage. And then this will be sent back to TimeWolf, and TimeWolf will send it to TimeSketch for analysis. So this all happens in one CLI command, but where libcloud forensics really helps is right at the beginning of the process, where all the steps that Theo detailed before, the snapshotting of disks and the moving the snapshot from one project to the other, the creation of a disk, the removal of the initial snapshot, everything is automated and abstracted away. So you as a library user can have all these functionality, and it's really embedded into another and bigger forensics pipeline. What about Amazon?
Let's take a look at Amazon. So we have a similar story, compromised instance. We have three key differences. Well, we're in AWS, that's one. And then the disk that we want to investigate uses AWS EBS encryption. So for those of you that are not familiar with AWS, EBS encryption is the way Amazon ensures the security of your data at rest and in transit between instances and storage. And the third difference is that we want to analyze the disk in a different AWS account. Since we don't have the notion of projects in AWS, this is basically what we have to do if we want any kind of separation between wherever we have our compromised instance and wherever we want to do the analysis. Now, can we do all of this through AWS Web Console? The short answer is yes. The long answer is yes, but you really don't want to, and I'm going to show you why. So in the picture in the slide, you can see what the steps look like if you were to do it manually. The upper part is everything that's happening in the source account. The lower part is everything that's happening in the destination account. The green circle that's in the slide is the volume that we want to make a copy of. It's encrypted, and it's encrypted with the default Amazon key that comes with your account whenever you create an AWS account. So the first step is similar. You create a snapshot, but now there's a catch because AWS does not allow you to share the default encryption key that comes with your account. So you have to navigate your way through the UI and go to the key management service and create a temporary customer managed key, which you have to then use to create a copy of the first snapshot, which you will re-encrypt with this temporary key. And after that, you have to share both that copy and that key to the external account, which is the last grid circle. So then you have to log off and then log in the destination account, create your final volume copy, which will be automatically re-encrypted a third time with your default account key. But that's not it, because then you have to log off again, log back in the source account and do some cleanup work. So you have to delete the first snapshot, then delete the key and delete the third snapshot. So things are really getting ugly, and it's a long process, very tedious, and it's very easy to make mistakes or to forget to share things. So instead of doing that, you can do it the cool way and just use libcloud forensics. A one-liner, again, you just reference the volume ID, type your command, launch it, everything will be done for you. So when you launch this command, libcloud forensics will check if you're trying to make the copy in a separate account. If so, it will also check if you're trying to make a copy of an encrypted volume. And if so, it will generate everything for you. So it will generate a one-time key. It will re-encrypt a second copy of the snapshot, share everything with the destination account, connect to it, create the volume, connect back to the first account, clean up everything, and then you're done.
Cool. Yeah, thanks, Theo, for the insight on that. I'm going to anticipate one of the questions that we very often get, which is why do you people produce all these code in open source? Well, there's a few good reasons for that, right? The first one and the main one is we really try to be platform agnostic. So basically that means that we never really know what we're going to do forensics on next. It could be something on GCP, it could be something on Azure, it could be something that is internal from the systems of Google. It's really hard to know, but we really want to make sure that we keep like this agility and that we can adapt. And for that, we need a platform agnostic software. So this is true for all our tools, but for this one in particular, there's another reason that is really important is that we want more diverse feedback on the usage of the tool. So that means that, you know, we're pretty heavy users of GCP and less heavy users of AWS, but it could be that someone else who uses this library is a very heavy user of Amazon Web Services. And, you know, they will know much better than us what are the things that they want to see in this library and how do they want to use it? How do they want to integrate it with their own tools? So we're looking for different use cases. We have a very GCP-centric bias, and we're looking to unbias a little bit this approach. And we're also looking for different experience with more and other different cloud providers. And last but not least, we also want to give something back to the community. We spent all this time writing code, might as well have other people work on it too, right? Or benefit from it at least. We've also been experimenting a little bit with code review experiments because this, in our team, it's a fairly new library and the code base is unfamiliar for many people. So for that, we've experimented with a little bit with GitHub code owners, which basically declares user accounts and maps it to specific sections of the code where they have, let's say, review authority over. Well, in our case, because this is very preliminary, all the main 4 contributors are all code owners of the whole code base. But the main change that we made was to have 2 pairs of eyes for each code review. So you might think this makes things way heavier when it comes to code agility, but it doesn't, because from what we've seen, there's much less reviewer fatigue. So it's not always the same person who reviews the code. We have this rotation going on where we pick 2 people kind of at random or that are more familiar with some parts of the code base. So there's much less reviewer fatigue because there's no one reviewer that will review all the code or all the pull requests. There's also less pressure on reviewers because if I come in as a second reviewer, I know that the code has been through a first round of reviews. And if I come in first, then I know that probably the second person will also catch some mistakes that I may have not seen, right? And this also adds a lot of different perspectives on the code and the way it should be fixed when mistakes are made, whether it's style or, you know, optimizations. It's really good to be able to learn from your teammates that are also reviewing the same code. And yeah, you learn a lot from comments that other people make. And last but not least, we also wanted to have a bigger part of the team work on this code base. And this was a bit tricky because we have sites in many time zones. We have sites in the West Coast, in the East Coast, in Zurich, and in Sydney. And getting all these people to work together on the same code base can be a challenge. So naturally, this started off in Zurich, but we want to export the knowledge of the code base to other sites. Because if, you know, something happens and we're all sleeping in Zurich and everyone is awake in Mountain View or in Sydney, then they will have to wait for us to wake up to fix bugs. And that's really not good, especially in an incident response environment where you need to have this agility. So what we want to be able to do is have people who are knowledgeable enough in every site or in at least one of the sites to be able to fix bugs that come up. We also want to share maintenance responsibilities. So if some people in one site, they just take time off, well, then someone else can come in, fix bugs, write documentation, and so on. And we also want to split code reviews because it's pretty cool to be able to say, I wrote some code on a Friday evening, and then I just want to, you know, have it reviewed and ready to go by Monday. And then maybe people in Sunnyvale can take over their shift and review the code, and then I can keep working on it on Sunday morning, and I don't have to wait for the whole team to review it when they're in the same time zone as me. So that's also pretty good. We also try to make a lot of efforts in our continuous integration and continuous deployment pipeline. So you may think CI and CD is really a software engineer thing, but let me assure you it's not. I don't consider myself a software engineer, more of a security engineer, because I like to focus on features that my code does and how it helps me tackle the problems that I have. I care little about coding structure and things. It's important, but what I want to focus on is features, right? So by this, I want to automate as much of the quality assurance as possible. So I want to have my tests run every single time that I receive a pull request. And this is super important because you want to be able to merge with confidence, right? You want to be able to say, well, I'm going to merge this code into my main code base, and I want to have a certain amount of confidence that it's not going to break everything. So that's pretty good to have unit tests, and we use GitHub Actions for that, and it's been really good so far. We're also using end-to-end testing through Jenkins. And that's also pretty good because it allows us to detect API changes early. I mean, libcloud forensics is all about interacting with APIs that we have little control over. So, you know, you don't want to wait until you're in the middle of an incident response just to find out that an API method that you were relying on has been deprecated. You want to know this early on, and it has already caught a few things that were really good to have and to fix early on before we're using it in an incident. This is an awesome sticker, by the way. So they ship everywhere. About code quality. So we use type hinting a lot, which is a new feature in Python 3. It makes Python a little less YOLO and allows you to have a little more structure when you try to specify types and things. It makes things a little bit more consistent, and it will also catch a lot of errors very early on. We also have linter checks, and linter checks allow us to have a certain type of consistency across the entire code base. Because, you know, there's like 5 people working on this code base, and we all have different coding styles. Some people come from Java, some people come from Go, and it's fine. I don't judge, but, you know, I like to have my code consistent and at least not be able to obviously tell who wrote this function. So linters help us a lot with that, and we also have a style guide that we follow. We also try to work a lot on documentation. We have very verbose doc strings, and that will hopefully be very helpful when we decide to generate all the docs for our code, which we haven't done yet. We also started off having an examples directory, which turned out to be so useful that we decided to turn it into a CLI script directory, because this was exactly how you were supposed to use the code. We also make heavy use of GitHub issues. There's a very big culture in our team to please open issues every time you have an idea or a bug or something that you want to write down so as not to forget it. Just open an issue, and then someone will triage it and label it. And to triage issues, we use labels. As you can see in the screenshot there, we have labels for GCP, an enhancement label, which is basically a feature request label. We have Azure. We also have testing. We have documentation. We also have a good first issue label. And that's really useful because newcomers to the code base that want to contribute, they may want to have easy things to tackle first. So this allows us to say, like, hey, maybe take a look at this issue first. And, you know, that will give you, it's not really challenging, but it will give you a good overview of how the code base is. We also try to maintain a public discussion. It's not very easy because we're all in our internal messaging tools, and, you know, Google already has a bunch of them. We don't want another one, but we really try to keep the discussion in issues and pull request comments and so on. We also have a Slack channel where you can find us if you're ever using this. There's a link right there. The link is a GitHub link, but the GitHub link has a link to the app to add you to the Slack channel. So follow that if you want. We'll repost the link later on, and it will be in the slides anyways. What about a roadmap? What's the future for libcloud forensics? Well, we have a GitHub project page, which is the screenshot that is here. It's part of the project page, where we try to put what everyone is working on so that people can have an idea. And by people, I mean us for now, because I guess we're the people who have the most interest in knowing. We have a horizontal roadmap, which is basically support basic functionality, but for more cloud providers. And we're currently working on Azure. But, you know, if this is something that you're interested in, then maybe you can contribute for your own cloud provider. We also have the vertical roadmap, which is support more features for a single cloud provider. So, for instance, more disk operations in GCP to have, for example, an instance disk become a DD image. That could be useful. And also more granular support for logs, like, for example, all the logs that GCP supports, but also CloudTrail from Amazon and all the other logs that they support. And we also want to focus heavily on community. So I'm trying to come up with a contributors guide that I hope to publish soon. And we also want to focus heavily on documentation so that people who want to use something like this can do so very easily. The link below is a link to our GitHub project page. You can also find it through the repo if you click on the projects tab. And that is about it for us. Thanks for listening so far. If you have to remember one thing, remember that libcloud forensics is a thing that can help you do forensics in your cloud providers. And here are all the links you may want and need from this presentation. So we talked about TimeWolf, Turbinia, which are tools that we use every day, and then the Slack channel and the blog are right there. And the blog has been pretty active recently, and we published a few articles about libcloud forensics, but also our other tools. So if you're curious about what we're doing, feel free to have a look. And I guess we can take questions now.
Effectively, we have got some time, so we can applause first. And effectively, we have got one question up there.
Where do I see it? Well, you can probably read it.
You
out
can
loud, but...
take the question in the Q&A
button.
query button in the interface, Zoom interface.
You can read it out if you want.
Yeah, the interface disappeared. So
yeah,
I will read it out. It says we will be able to choose parsers while running Plazo. That's the question. Or all parser will be run automatically with Plazo.
Okay, so that's a really good question. Not about libcloud forensics, but I can still answer it. So you can select what Plazo versions to use, Plazo parsers to use when you run Plazo. But I assume this question is more about how Turbinia decides to run Plazo and which parsers it decides to run. So one of the features that Aaron, who's working on Turbinia, is working on right now is to have some sort of recipes with which you can launch Turbinia. And in that case, you could say, hey, Turbinia, I want you to run Plazo, but I only want you to run very specific parsers, or basically run Plazo with these options. Just like you could have, please export it to TimeSketch, but only run these specific analyzers, or maybe even, just run Plazo and don't run strings on the whole disk. So yes, this is customizable in Turbinia. In Plazo, it's already a thing, so you can just pick the parsers that you want. And Turbinia will soon be implementing this recipe mechanism, which is a little bit more complex.
Another one question, I can read it. I think it is a kind of troll, but you have to, we have to deal with.
I will play along.
Tip hinting makes Python less YOLO. Why use Python at all if you want type safety?
Okay, that's a great question. I don't think type safety is something that we want. It's always good to have it, I think, and it's something that Python really lacks. But the main question is why are we using Python if we could be using any other thing? The main reason is because all our other tools are already Python. For example, DF TimeWolf is already Python. So importing libcloud forensics would be very easy in TimeWolf and in all the other tools that we use. So let's say that this is our code base that is maybe the cleanest in that way with type hinting. So yeah.
Okay.
I can actually see the questions now, so that's much better.
Yeah, perfect.
But there's no questions anymore. Oh well.
maybe one more. If you run yourself the forensic analysis, can you give us an idea on what scale or how many cloud instances you can actually examine or analyze with these tools at once? What is the scale? Okay. What is the goal in terms of scale?
Okay, that's a good question. So the goals in terms of scale are to be able to scale, right? For now, it is true that we haven't considered parallelizing libcloud forensics or its functionality, but the main time sink in doing this won't be situated in the cloud forensics library. It will be more waiting on the GCP platform to actually do the actions, right? So in that way, it would be fairly easy for us to just, thread the CLI invocation in a bash script or something. So that would work. On the other hand, Turbinia and TimeSketch are really made to be able to scale a lot. And Turbinia can deal with a lot of disks at the same time. It's like running Plazo in the cloud, but on a very, very beefy VM, right? And TimeSketch can also deal with hundreds of timelines at the same time. So these two other tools are really made to scale, and TimeWolf is made to orchestrate all these tools between them. So yeah.
Okay.
Theo, did you have something to add to the typing question? Because I saw that the notification said that you would answer something.
Oh yeah, I was just clicking buttons. But
okay.
I guess it would be worth adding, it also just helps us catch mistakes, because Python being Python sometimes just write things and you might overwrite variables or whatever, and then pass to some function, something that's really not expected. And so rather, instead of waiting that it just explodes when you're actually running the tool, we can just use type hinting to help us catch this earlier and just make sure our tools are safe to use, so to speak.
Okay, so no more question in the audience. We have got around 10 minutes ahead, so we can stand by and take another pause, or we can also switch to IRC if you want to chat. The question on Python has been asked at the first time on Freenode, so.
Right, I can join the IRC channel and deal with the trolls over there. It's fine.
Yeah, it's okay. It's okay. So we take a 9-minute pause before the last talk with Tom about Frida and QBDI. So see you there.
Okay. Thank you.
Thank you very much.
Christophe, t'es mute.
Yeah, it's better if I unmute. So thank you, Philip. Well, we are back for our last talk of this afternoon. We are going to welcome Tom Cheka from Quarks Lab, talking about combined advantages of Frida and QBDI on Android. Tom, the stage is yours.
Thank you. Can you hear me?
Yeah, perfectly.
Okay, cool. Okay, so let's share my screen first. Can you see my screen? I hope so.
Yes, full screen for the moment with slides.
Okay, that's perfect. Okay, so here we go. Hello, everyone. Today I'm going to talk about how Frida and QBDI can be used together to make reverse engineering easier on Android. So first of all, quick introduction. Who am I? I'm Tom. I work as a security engineer at Quarks Lab, which is a security company based in Paris. I'm mainly interested in stuff related to Android, like reverse engineering, instrumentation, fuzzing, and tooling. Yeah, so that's pretty much all for me. Before we get started, I will give you some background about Android reverse engineering. For some of you, it may be something you already know, but I want to make sure that everyone is okay with this concept before, digging into the following parts. Okay, so let's begin with Android application ecosystem. So Android programmers develop their application in either Java or Kotlin languages. Then this code is compiled into Dalvik bytecode. If you're interested in knowing what this bytecode is about, you can have a look online. After that, the bytecode is stored in DEX files, which stand for Dalvik executable. And finally, these files are embedded in the final APK file, which basically represent the application. When it comes to running the application, this code needs to be executed. So before Android 5, it was done thanks to a virtual machine called Dalvik VM. But since performances weren't that good, it was next replaced by another approach called Android runtime, which consists of compiling ahead of time the Dalvik bytecode into machine code, which can be executed natively on the CPU. Regarding reverse engineering, there are some tools out there, such as JDX and APK tool, to help you read through a human readable representation of the code. That way you can retrieve something that really looks like the original code. On top of that, Android, especially Java, provides an interface to allow developer to write and call native code from the Java side. This mechanism is called Java Native Interface, which is often just shortened JNI. Technically speaking, the code is put into a shared library, which is embedded in the APK file and is loaded into memory at runtime. So now reverse engineering is more difficult because you need to deal with native code. Okay, so now let's pretend you're a developer and you want to protect your encryption function, which is basically a simple XOR function because you're really good at cryptography. You can see that when you decompile the Dalvik bytecode into Java representation with JDX, everything remains pretty much the same except function and variable names. It's mostly due to ProGuard, which is an optimizer which provides minimal protection against reverse engineering. So that's not a really great idea to write sensitive function like that, because an attacker could understand it without effort. Okay, so now let's shift this function to the native side. So of course, you need to pass buffer length in arguments, but the logic is pretty much the same. We can try to compile it and see what the graph looks like in the disassembler. Okay, so if you choose not to use an obfuscator, we can more or less easily understand what this function is doing. I mean, at the top of the function, the first basic block is presumably responsible for initialization. Then we clearly see a loop with the loop condition. On the left, the processing block, which contains the XOR instructions. And on the right, the epilogue of the function. Now, with obfuscation, it's like much more complicated to understand what's going on because, I mean, at least statically, because OLLVM used some obfuscation technique like flattening to scramble the control flow. So it's just a pain to understand that this function is actually a simple XOR encryption. So we need another approach. We can still try to understand what this function is doing dynamically with a debugger like GDB or LLDB. There's many techniques out there to detect the presence of ptrace, and developers often rely on them to protect their application from being debugged by attackers, so it's not really practicable. Oh. Okay, so now let's introduce FRIDA. I suppose most of you already know FRIDA, especially if you're into mobile security. Basically, FRIDA is a GBI toolkit which allows user to inject some code into a process. In the context of Android, it's rather application. Unlike debuggers, only injection relies on ptrace, so it's harder for a process to notice it's being inspected. But for example, you can inject the FRIDA library on your own without using the injector. FRIDA is widely used on Android because reverse engineer can run the FRIDA server on remote devices, develop and inject their script directly from their host machine. So it's really convenient, and they can debug at both Java and native level. So it's really powerful. In practice, how does it work? First, we need to find the address of the function we're interested in and declare callbacks, which will be called before and after the function is called. So that way, you can print the arguments passed to the function and the return value. However, we still face some limitation here, as you can see, because we can print arguments, but we're not able to understand how the function processes them. So that's where QBDI can give us a hand to deeper understand this function. Okay, so first off, a quick introduction of QBDI. QBDI has been initially developed by Cédric Tessier and Charles Lubin when working at Quarks Lab. Like FRIDA, it's a GBI framework, but it has been designed another way. Indeed, it's based on LLVM, and it rather work at basic block and instruction scale. And yeah, that's why it can help us get an accurate understanding of the function we're looking into. Okay, that's cool, but how to use it? A GBI tool doesn't instrument the whole code because it would be like a pain in terms of performances. As a result, we need to explicitly specify some parts of the memory we're interested in. It can be a whole module or only a specific part of it. You can also instrument the entire address space, but I highly discourage you from doing so because it's super heavy and there's a few use cases where you need to instrument all the process. So yeah, it's not a great idea. Then in order to tell QBDI what you want to gather, you need to define what we call callbacks. Basically, a callback is a function called whenever encountering a specific situation. For example, before, after executing an instruction, when you come across a new basic block you haven't seen before, or when the code jumps to a range that isn't handled by QBDI, it's like really useful for getting a dependency like library calls, for example. Okay, so that was theory, but now let's play around with the C++ API with a quick demo. So I'm gonna detail all these steps while showing you the code. So I hope it works. Okay, I hope you can see my screen. So the scenario is we have a library called Strong Crypto, which contains an interesting function called InPlaceEncrypt. Basically, we would like to generate an execution trace of this function. So first of all, we need to load the library into the process memory. So it's just a call to dlopen. Then we need to find the address of the function with dlsim. Then we need to set up the arguments that needs to be passed to the function. So there's only 4 here. So here is the key, the length of the key, the message, and the length of the message. And then we can execute the function through QBDI. So let's have a look at this function here. Okay. First of all, we need to create the QBDI VM. Then we need to locate a virtual stack here of size 100 in hexadecimal. We need to define the range, the instrumented range. So here is like the whole module the function is contained in. We need to define a callback. So here, this function will be called before executing instruction. This function only is responsible for printing the current address and the disassembly of the instruction. Then we need to simulate the call. It means to prepare the registers and the virtual stack with arguments and the return value. That way, QBDI can know when the execution is over. Then we just run the functions through QBDI, get the return value, free the virtual stack, and just return. Let's run it to see. Okay, so let's compile it and just run it. Okay, so it seems great. Sorry. We have the address and the disassembly of the instruction, so that's good. Let's get back to the slides. Okay. So now, what if we could combine like FRIDA and QBDI like together? To do so, we're gonna have a look at the concrete example. I suppose that everyone here has already heard of WhatsApp, which is currently the most downloaded instant messaging application. So it could be a great fit for a great target for us. We've noticed it embeds a library called libWhatsApp, which contains a large part of their code. Since it's a GNI library, the first function called right after the library loading is GNI unload. This function is worth inspecting because developers sometimes use it to hide some secret mechanism in it. In order to understand what this function is doing, we would like to know which part of the code are actually executed. For example, like we just did, we could generate an execution trace containing every instruction that has been executed from the beginning to the end of the function. I mean, including subfunctions. The idea is instead of letting the function run as usual, we could execute it through QBDI. In practice, we can take advantage of the replace feature of FRIDA to change the real implementation of the function. So we're gonna set up QBDI with the proper context, execute GNI unload with QBDI, and then forward the return value to prevent the application from crashing. like resume the application normally. So let's have a look at the implementation to better understand how to set it up. Okay. Okay. So here is the Frida scripts. First, things like libwhatsapp will be loaded dynamically. We need to wait for it to be loaded in memory. So yeah, we need to wait. To do so, first of all, we need to attach the GLOpen implementation of Android. So here, check the first parameter, which is the file name. And if it's the right library, we just call the replace function here. And we're going to have a see at this function. Okay, so this function is responsible for replacing the implementation of GNI Unload. First, it needs to like revert to the initial implementation because Frida has instrumented the function, and then we need to make sure that changes have been committed properly with the call to flush. Then we need to execute the function through kubedi and call this same function again, just because if GNI Unload is called at some point, we just need to call this new function and not the real one. In the case of GNI Unload, it's supposed to be called only once, so there's no issue. It's just for genericity. Okay, so let's have a look at the execution function, the kubedi execution function. It's almost the same that I showed you in C++, except that now we need to synchronize CPU register with kubedi once to avoid some side effects. Yeah, and that's pretty much the same. We need to create the kubedi VM, allocate the virtual stack, instrument the module, and etc. Call here we call the functions through kubedi in the context of kubedi, get the region value, and synchronize back the context if needed. And yeah, that's pretty much all. Let's try to run it. Oh, not really. Okay. Here we go. So first of all, we have to compile the code to be able to access the Frida bindings. Okay, it was long. And now let's try to spawn the WhatsApp application with the script. Okay, so it seems to work. We have the address and we have the disassembly of the instruction. So yeah, it seems to work. I don't know if you can see like the emulator. Okay, so it works. I think you can get back to the slide. So here we go. Having an execution trace like that is great, but not really convenient to inspect, to be honest. I mean, it's not as visual as it would be in a disassembler with GraphView, for example, when you can clearly see conditional branches, loops, and so on. So a good option could be to integrate this information in a disassembler like IDA or Ghidra. Now we aim to generate a code coverage file that can be imported into both IDA and Ghidra. Fortunately, this can be done natively, but instead we need to use external plugins like Lighthouse and DragonDance. These two work with GLCOV files to colorize the executed blocks, executed basic blocks. So the idea is to reuse the previous script to gather information we need, like memory layout and the basic blocks that have been hit throughout the execution, and finally generate a code coverage file that can be loaded into disassembly. So let's see what it takes to make it work. Okay, just here. Okay, so as you can see, the script is pretty much the same. That's the one I just showed you. However, now we need to run the script from a Python code we control. Basically, the Python side will receive information from the JavaScript side and will be responsible for creating the output code coverage file in the proper format. So as it's not really interesting, we're only going to focus on how to retrieve runtime information we need, like modules and basic block with QBDI. Okay, so we still need to wait for the function to be loaded. If it's the right function, we just call this part of the code. But before replacing the implementation, now we need to send the memory layout information to the Python side. So with this function, it's just the module that has been loaded into memory. Then we call the replace function, which is exactly the same. And we just execute the functions through QBDI. So yeah, now we don't need to generate an execution trace. So we need to place a callback at every instruction. Instead, we need to declare a callback that will be called whenever a new basic block is discovered. So it's just this VM event here. And this function is called. Basically, this function is just responsible for getting the module, the module, of the basic block is contained in, the offset from the base address of the module, and the size of the basic block. It just sends this information to the Python side, like that. Okay, so now let's try to execute it. If okay, so we still need to compile the script. Okay, and just try to, I don't know if you can see, and just run the Python script to tell that we want to run WhatsApp and just generate a code coverage file. Okay, so working, okay. So the file has been written. So let's check. Okay, so now we have this file here. Let's try to import it into Hydra. So here is Dragon Dance. So we can just define Jericho file. Okay, it has been imported, and we can just try to colorize what has been executed. Okay, so that's really cool because at a glance, we can exactly know what has been executed. Yeah. So for example, let me search for a function, for example, here. Okay, yeah. So for example, here we can see that this block, and this block have been executed, and this block, and this block have not. So it's really visual. And thanks to Dragon Dance, we can also know what's if you have multiple traces. I don't know if you can see it, but you can know what's similar and what's different between several execution traces. So it turns out to be really convenient when it comes to comparing some traces. Yeah, okay, so let's get back to the slides. Obviously, this technique works with every native function as long as you know how many arguments it takes. And you can define whatever QBDI callbacks you want depending on your needs. So here it was about discovering new basic blocks, but you may want to, I don't know, record execution transfer or memory accesses. Yeah, so just to wrap it up, there will be a follow-up article which will be probably published in the next few weeks on the Quarks Lab blog. So if you're interested in trying this out on your own, just stay tuned. It will it will be like a review of what we've seen today. And that's pretty much all for me. Thanks for listening and attending this webinar. And if you have any question, like, feel free to ask on the chat. Thank you.
Thank you very much, Tom.
Yeah.
Well, do not be shy. We have got time and time for question. So, so Chanel is yours, dear attendees.
Maybe just
maybe a question with the panelist. No question? Good question?
I think so.
You have been too clear, Tom.
Yeah.
So, Philippe, nothing to add on your side? Maybe you don't hear me. You're just digging. So, you will be able to join Tom if you want. If you had in the future. One question.
Yeah. So so have you used similar method to debug embedded system other than Android? To be honest, no. But it's possible. The only limit is that for now, QBDI only supports x86 and x86 and x64. Sorry, but yeah, you can use it if you're running embedded system using this architecture. But I'm not sure you can find a lot, to be honest. But the ARM support is supposed to be released. I mean, hopefully soon.
Perfect. Another one? No? So I think we can stop there. And finally, thank you very much for this talk. Tom?
Thank you. Thank you.
Bye.
Bye.
And so we will end this afternoon. So we will be back tomorrow afternoon at 2 p.m. with red teaming in the first time, then detect and defend and in the second half of the afternoon. And we will end the afternoon with a concert with Clément Capitaine. So have a good evening. We are going to release the slides in the evening, and we will be back for the video, but later on in the following weeks. We are going to release all the slides very quickly, and follow Twitter account for the availability of the video. So thank you very much for this first afternoon, and see you tomorrow. Bye.